Welcome. My name is Teddy Lee, class of 2017, and I am very pleased to introduce our guest speaker, Christian Catalini. Christian is an assistant professor of technological innovation, entrepreneurship, and strategic management at the MIT Sloan School of Management. Christian's research focuses on blockchain technology, cryptocurrencies, the economics of equity crowdfunding and startup growth, and the economics of scientific collaboration. Christian is one of the principal investigators of the MIT Digital Currencies Research Study, which gave access to all MIT undergraduate students to Bitcoin in the fall of 2014. He is also part of the MIT Initiative on the Digital Economy and the recently launched Digital Currency Initiative. Christian's work has been featured in the New York Times, the Wall Street Journal, Forbes, TechCrunch, and Vice News, among others. Today's session will focus on the economics of cryptocurrencies and blockchain technology. Christian will explore how these emerging technologies will affect the digital economy, established incumbents, and the ability of startups to raise early-stage capital. Please join me in welcoming Christian Catalini.
Good afternoon, everyone. It's a great pleasure to be back at the Sloan reunion. I remember a few years back, we were talking about crowdfunding. You know, the technology space has moved quite a bit. When I started studying crowdfunding in 2007, it took, the leading US platforms 10 years to raise $3.5 billion in capital on the platform. And that was already a massive success. More capital was allocated to the arts and to artistic and creative projects by Kickstarter than the National Endowments of the Arts for the last 5 years. But this part of the space has literally obliterated any record in crowdfunding within the span of the last 18 months. More than $8 billion of capital, for good or for bad, and you'll see there's some bad in it, has moved all across the globe to entrepreneurs that are starting new types of ventures of very different types in different verticals, in different industries. But before we start, just to get a pulse of the room, how many of you have known, have explored enough of the Bitcoin, cryptocurrencies, and blockchain space to have a basic understanding of the phenomena? That's really good. That's why I know we're at the Sloan reunion and not somewhere else. How many of you have learned enough to be dangerous in this space? Know some cryptography? Okay, a few. Good. So let's try to make this a conversation. Feel free to jump in at any point in time. I have plenty of slides, but I want to make this very interactive. What's been?
Don't go behind this pole.
Okay, that's going to be hard. That's going to be extremely hard because I do walk a lot in our classrooms. Okay. Let's see if I can do this. Since we did the MIT Digital Currency Research Study at the beginning of 2014, the phenomena and this entire space has exploded. The spike that you see, that's Google search volume for the terms cryptocurrency and blockchain at the end of 2017. A different way to think about the acceleration that's been taking place here is when we dropped about $500,000 in Bitcoin to our undergrads in 2014, the majority decided to keep their Bitcoins. So everybody was receiving $100 in Bitcoin, and all my economist colleagues were asking me, why isn't anybody spending it? Now, it turns out that we had asked the undergrads, what do you plan to do with your Bitcoin? And the answer was, I plan to keep them as an investment, which turns out wasn't such a bad idea. So never underestimate, 4,000 MIT undergrads. The returns on those $100 have been, depending on a moment in time, somewhere between 30x, which is kind of a low point, actually, and they were like 50 to 60x in December. But that's just to give you a feeling for how quickly something like Bitcoin has really moved in terms of financial acceptance, futures market kind of developing, derivatives markets coming in on something that until a little while ago was considered the realm of pirates online and cypherpunks. The first thing to keep in mind when approaching this space is that there are many competing standards. The space is in a completely fluid phase, and so no matter what different people are going to claim, we don't know which one the big platforms of the futures in this space will be. People have different opinions. But one thing is certain is that at some point we were almost headed towards a .coin bubble. So if you go back to the .com days, the hype enthusiasm and the disconnect between what the technology can give you today and what it can give you maybe 5 or 10 years into the future was massive. And things have kind of sort of come down, but we're still in a phase where there's a lot of confusion. There's not a neat separation between high-quality entrepreneurial teams and people that are selling snake oil. People that are making real, thoughtful investment decisions, and people that are just following hype and the fear of missing out on the next Bitcoin. So that's kind of the moment we're in, which is exciting for people like me studying this, because on one side, the technology is evolving rapidly, but the market use cases are also evolving quite rapidly. We still don't have a cryptocurrency that can be defined as such. In fact, I'll argue that they're all crypto assets today. This actually came out of a long conversation with Roberto Rigobon, which I know you've seen this weekend too. A currency has to do a lot more than just become some sort of digital gold or store of value. Right? It needs to be a meaningful medium of exchange, something that retains that value, that is not as volatile as Bitcoin and all the other cryptocurrencies are as of today. So if you look at the classic Gartner hype cycle curve, turns out that they build these curves exposed. So I had a lot more respect for the curve before I discovered that they build them after the fact. The first time they placed cryptocurrency on the curve is when it was essentially at the top of the hype. Another way to think about this is that even if you take the most established blockchain out there, Bitcoin, even within that platform, there's kind of a civil war between what should Bitcoin be. Should it be something like, again, digital gold, something that retains value and has all the properties of gold, but it's just digital? Or should it actually really become a cheap medium of exchange, something for payments? And those battles for the standards are something that we see in technology all the time. Think about DVD versus Blu-ray. A number of these iterations were, Sony versus, so the Betamax versus VHS. Until those are resolved, it's hard to build applications on top, because if you're an entrepreneur, you'd like to know what are going to be the fees if I use Bitcoin versus some other cryptocurrency or not. And this kind of is the visual representation of that battle for a standard within Bitcoin. Those two lines represent different opinions about what Bitcoin should be. And you can see that it's based on days. So those are people voting, miners voting their trajectory for the cryptocurrency. And at a moment in time, there was such a fierce battle that people really didn't know which way this would essentially turn. In the background, I think the other thing that's been happening is that people have realized that you can use these new instruments to raise tremendous amounts of capital extremely quickly over the internet. And so whenever you remove frictions, there's two things that happen. On one tail, people that could not be funded by traditional angels and VC maybe now have an access to another source of capital, and that's potentially positive. But of course, there's a lot of opportunistic entry. People that see this as a get-rich-quick scheme and want to exploit the fact that you sprinkle a blockchain keyword on an old company, and suddenly investors get excited again. Initial coin offerings, which is essentially the sale of these tokens to the public on a global scale, completely unregulated at the moment in most jurisdictions, have completely eclipsed venture capital financing in this space. So that's kind of what that graph shows you, and I'll go into more detail with some of our new data on that. But before we do all of this, for those of you, for the minority that maybe hasn't read enough about blockchain yet, let me give you the definition that essentially all you need to do about blockchain to kind of go through the talk without any problems. So for the purpose of today, think of a blockchain as a chain of blocks. Okay? So we start with the basics. The word gets you 80% of the way there. Now, what's interesting, and that's why economists are excited, it's that what you save, what you record in those blocks is really up to you. And so in something like Bitcoin, you're recording what people call unspent outputs. Think of them as almost like balances, ownership in a digital asset. But why not record ownership in a company, equity, or contracts, or any sort of digital bit of information that is valuable, intellectual property? If it's recorded on a data structure like that, the trading, settlement, reconciliation on a global scale becomes extremely simple. In fact, that data structure allows you to do self-custody of digital assets in a way that you couldn't do before. Most exchanges, most marketplaces you use today actually control the digital assets that you use. You never own your digital assets. With a structure like this, and this is why it also relates to privacy, ownership and control of those digital assets, and currency is one type of digital asset, is really in your hands. And so this opens up a number of new business models, a number of new approaches to really designing digital marketplaces. Now, the confusion starts because people tend to think that this has all to do with computer science. But we're at Sloan, and so my opinion is that this has a lot more to do with incentives, with the way we align incentives in a digital ecosystem. The technology behind Bitcoin had been around for multiple years from a computer science perspective. The breakthrough was in thinking about adding incentives in an economic system and creating essentially a new type of digital platform. And I'll expand more on that in a second. So where is the breakthrough from an economics perspective? Right? So if we take a step back and really try to think about, if you want an algorithm for looking at any problem that you may face in your businesses every day, in startups, in incumbents, and say, is this a problem I would use a blockchain for versus not? What should that algorithm be? If you talk to many of the entrepreneurs that are building interesting platforms in this space, you keep hearing this term of censorship resistance. And this is where you lose actually often half of your audience, because censorship is not something that we worry on a day-to-day basis in most countries. And it doesn't really map to a business concept, because we think about governments when we think about censorship. So let me translate what the computer scientists are saying to something that I think you're facing every day when you're essentially doing business. And what that is market power of a specific type. The type of market power that has emerged with the emergence of digital platforms. So take any digital platform that you know, love, and use today. It has accrued tremendous market power for a very simple economic reason. We enjoy the benefits of network effects. Think about the telephone network. Right? If you're the first user of a telephone, it's not that useful. You can't call anyone. But as more users join the telephone network, the value of that network increases in value. Often exponentially. I mean, people have modeled this in different ways. Before Bitcoin, we didn't have a way to build a digital platform without assigning a tremendous amount of market power to the entity running that platform. So pick any service today. It could be Google, could be Facebook, could be Uber. Right? We want to be on the same network. And in fact, often we multi-home. Right? We're running multiple apps. Both think about drivers and customers. Right? You can switch almost seamlessly. But as a result, these platforms have access to data. They have full visibility on the marketplace. And they can exploit that, either with higher prices or with keeping competitors out. But at its core, we didn't know how to reap the benefits of network effects of platforms like the telephone network, right? Or even think about VHS, right? The fact that movies are a complement to that platform, and so the technology has both direct and indirect network effects without assigning tremendous market power to the players. Now, what Bitcoin does, and the technology behind Bitcoin allows you to do, is to bootstrap and operate digital platforms in a fundamentally new way. And this is why anyone in business should care. It's much broader than cryptocurrency. It's much broader than even some of the applications that you're seeing about decentralized applications and so on. We have a paper where we go into a lot more detail about kind of the fundamental economic cost that the technology touches on. I'll give you the short version. So we talk about two fundamental costs. The first one is what we call the cost of verification. And this is kind of intuitive. It's the cost of verifying the attributes of a transaction in a marketplace. I'll elaborate on that in a few slides. The second cost is the more disruptive. It's the one that, if you don't understand the new economics and the new rules for developing business models in this space, you build them in the wrong way. And we call that cost of networking. And again, if it's unclear at this moment, I'll expand on that really soon. So let's talk about the first one. And I have to be close to the column. So think about everything you do on a day-to-day. If you're like me, the first thing you do, you check your phone, you're essentially downloading email from a server. So you're authenticating yourself and saying, OK, I'm awake. Send me those 100 messages that came in overnight. And that's a transaction. It's not a financial transaction. You're not paying directly. But it's a transaction between you and a service often. Then you probably buy something online or go out and buy a coffee or whatever. Transactions are pervasive in everything we do, both in business and as consumers. Now, we tend to forget this, but the attributes behind those transactions matter a lot. The reputation of the parties involved, their credentials. Let's say you just hired a new grad from MIT. Let's say he was a computer scientist, right? And after a few months, you realize, OK, I don't know if they're really good at coding. I used to remember MIT was better at this. Now you have to go back and verify, was that transcript that we received and we verified actually accurate? Or was it falsified? Verifying transaction attributes is expensive when problems arise. If the marketplace is run smoothly, you're just fine, right? If things go as usual, goods change hands, digital goods are exchanged, and everybody's happy. But auditing transaction attributes, it's something that in society we spend tremendous resources. In fact, I was recently talking with the DoD. Think about the DoD, right? So you have massive amounts of funds, and auditing that supply chain is extremely expensive. And large firms face essentially the same challenges. Now, imagine if I gave you a technology that makes it extremely cheap for you to audit any attribute as long as you've recorded it accurately on a data structure like that blockchain that I was showing you before. That's where the cost of verification really makes a difference. You can take the act of kind of performing verification in society and almost drive it down in terms of cost almost to zero. Now, as you will see, there's going to be a catch. And this is where often people get confused on what blockchain can and cannot do. Blockchain is going to be extremely good at digital verification. So the verification of attributes that are already born digital. That's why the first early, kind of all the early applications are in financial markets where assets are digital to begin with. Bitcoin, everything you need to verify and know about Bitcoin is on the Bitcoin blockchain. And all the problems, from hacks to fraud, are on the edges when Bitcoin actually interfaces with real people, with real transactions. So that last mile problem of crossing the digital space into the physical space is still going to be a concern here. And blockchain doesn't solve that. And that's why I think you're seeing slow progress on things like supply chain and provenance of goods. Because how do you record accurately what's happening actually in the real world back on a digital data structure like a blockchain? There's another aspect of this problem which is sort of interesting, which is how do we solve verification today? It's through disclosing a lot of the information needed. You sign up for a bank account. You're disclosing your social security number, a number of other attributes about yourself. You're interacting with a counterparty commercially. You're going to show a number of information bits to make sure that they trust you. And as data has become digital, it's become harder and harder to prevent reuse of that digital information in different contexts, and also protecting that digital information. If you essentially have a hacker breach through a system with a lot of centralized information, in a split second, they can start downloading gigabytes or terabytes of data. And so keeping information private, it's a major challenge. So we need a better system where we perform verification, we verify attributes of individuals, entities involved, without disclosing that information at every step. And that's where the way blockchain can change our approach to digital privacy becomes quite important, both in terms of ownership of your data, licensing of that data, use of that data. So think about data provenance for digital information. It's not random that Bitcoin developed in a marketplace that really needs digital privacy, which is the marketplace for illegal drugs online. But that degree of privacy can be useful in much more productive context. Think about your financial privacy or the privacy of your healthcare data, right? So we can take the same constructs, the same ideas, and apply them to contexts where data privacy is actually quite important. Credit scoring, right? Let's just think about the recent debacle at Equifax, right? Millions of records lost, because that data is centralized and it's exposed at every interaction, essentially. Now, when combined with something that actually has been developed a few blocks up at CSIL, Silvio Micali developed zero-knowledge proofs. You can take a blockchain, combine it with zero-knowledge cryptography, and now what you can do is I can verify that something is true without exposing the underlying information. So it's almost like, right now, if somebody goes up to a bar and gets carded, they're disclosing a lot to that bartender. And most of that information is not really necessary for that transaction. All that bartender is trying to assess is this person of drinking age, yes or no? Is a 0, 1, right? So imagine a scenario where you can verify attributes, that 0, 1, without disclosing anything else with security. That's kind of the promise here, and that's why people in healthcare are excited, people in kind of data privacy and security are excited, and so on. The other thing you can do, when the cost of verification almost goes down to 0, the one thing you can do is you can rethink about your digital systems and build data integrity in those systems from the ground up. Because now it's very cheap to make sure that every bit of information comes with integrity. Here's an example of a pilot at MIT. Your Master of Finance degree could be essentially recorded on a distributed ledger. Think of it as essentially a giant distributed database. And verifying that somebody actually completed their classes and has a real degree from MIT could be almost costless. That's kind of one of these examples where by building the data and essentially implementing it on a blockchain, you can really make it extremely cheap for everybody involved to verify that piece of information. Now, could you do this today with regular technology? Absolutely, right? MIT could run a database, and any employer, if authorized by an alumni, could check that and return essentially a positive or negative code. Is this one of our students? So you may wonder, why do I want a blockchain? Well, it's because now you're turning that platform for verifying credentials into an open platform. So multiple universities can come on board, different types of certifications, and then it becomes much more useful because you can start building services on top of people's credentials. So you're rethinking the entire process in a different light. Again, change of business model, change of economics, change of incentives. And why stop at credentials? What about intellectual property, equity, ownership in a startup? That's kind of one of the things that NASDAQ has been experimenting with, essentially incorporating a company on one of those distributed ledgers so that any change in ownership, when you have angel investors coming in and everything else, is kind of traceable through time and is always accurate. So that when the company goes IPO, you're sure that there's no skeleton hidden in some subsequent funding round that you discover too late. Contracts. You can have contracts verified and essentially checked with integrity in a much more efficient way in entire ecosystem. So we're not just talking about one company running their own internal system, but multiple parties from goods moving through the supply chain and going through Custom and Border Patrol, interfacing with different shipping companies and everything else. Everything tracked, everything with data integrity through the supply chain. Now, for this to happen, of course, a lot of things need to happen and change at the same time. And that's why I think with blockchain, we've been overestimating how quickly change will take place. Because in many of these settings, it's kind of a systemic change. You have to change everything to take really advantage of the technology. But they're also underestimating the long-run impact. Because we're fundamentally changing how value is created and captured in different industries. You're seeing application of this kind of drop in the cost of verification across the financial sector. So from cross-border payments to taking a financial asset and being able to move it quickly between institutions, between agreements, consumer payments, like essentially getting to a world where consumer payments are completely free across the globe. We have the technology to do that. The reason why it doesn't happen today, it's because of market power, private equity, and so on. All of these are not applications that really change industry structure. They just make certain things that we were doing before cheaper, more efficient, and it's essentially just doing cheaper settlement and reconciliation. Economists call this the intensive margin. So doing things that you were doing before, just potentially better. Other examples, micropayments. I mean, there's reasons why micropayments never took off, which is the behavioral cost, right, of thinking of, oh, now I have to decide if I want to micropay for this article or not. But in the back end, one of the reasons why micropayments and a wealth of economic activity that could be enabled by micropayments, which we don't even imagine today, right? Because it doesn't exist yet, the ability to really micropay for content or for any sort of digital material. Once you have micropayments in the paying infrastructure, you can do essentially the verification of those payments at a scale that you couldn't do before. And rethink entire business models like digital advertising, digital content, and so on. Now, the big elephant in the room here is the central banks. And there's multiple central banks around the world that are looking at the technology and realizing we can take this and kind of lower our costs. From, think about welfare payments that are extremely expensive to deliver. They're delivered in cash, right? To monetary policy and taxation, which could become a lot more efficient. Now, again, there's many ways to implement the technology. And there's ways to implement it in a way that looks a lot like cash, so you still have the privacy of cash. Or there's a dystopian implementation of this where the government can kind of see through every potential financial transaction at a level that was impossible before. And so I think you'll see very different implementation in different regions. Now, the United States is unlikely to be the first mover here because there's so much at stake. But there's a lot of interest in places like China, for example, where you keep hearing now, after kind of a cool down phase, especially around cryptocurrencies, that there's enthusiasm about blockchain in the government. And so what you should imagine is essentially a digital version of the yuan that allows a wealth of new financial services and streamlines a number of things that the government wants to do. I want to take a short step back and talk a little bit about what computer scientists call the double spending problem. Mostly because there's an interesting business implication of that, and that really relates to what you can and cannot do with blockchain. What is the double spending problem? So computer scientists for many years wanted to create digital cash. Now the challenge, if I digitize that $1 banknote and I send it to one of you and copy everybody else in BCC, you'll all receive the same exact banknote, like any other digital attachment, right? We can keep attaching digital goods and they all look alike. Bitcoin solved that problem. Bitcoin is a digital asset that cannot be copied. And again, how you can reach that kind of conclusion is through a mix of computer science and incentives. But the breakthrough here is that for the first time in history, we could create a digital good that is unique and that changes hands in the same way as cash. So if I have it, Balaji cannot have the same coin. And if he gives it back to me, then it's in my hands. The way we solved the double spending problem before Bitcoin was by placing an intermediary in the middle. You want to send digital money? There's plenty of services, right? PayPal in the middle, a bank, Venmo, pick your favorite. Essentially what that intermediary does, make sure that when the money leaves my account, it's gone from my account, and then it reaches Balaji's account, and things keep moving, right? So that transition, it's really important because once you take that intermediary out, well, now we can do money transfer at a much faster scale, cheaper, more efficiently, because we don't have to pay tribute to that intermediary in the middle. Now, of course, that intermediary may have done useful things like chargebacks or like other merchant services. Those will still need in a blockchain world, but the whole idea of moving digital assets will become extremely cheap. Moreover, when you think about move away from currency and start thinking, what can you do with this? You can create new type of digital assets that are actually scarce. And this is something that we couldn't do before. Digital assets before were easy to copy. They're easy to transfer, but they're also easy to copy. And in this new regime, you can actually start creating, and this is where it gets kind of counterintuitive because we haven't even seen what those things will look like. Take art, right? So art in the physical realm, if you buy a painting, you're buying the one unique painting until somebody tries to counterfeit it, right? But in the digital space, we didn't have that. So I think in the future, you'll see digital art that actually comes numbered. There's only certain originals, and there's going to be copies, very much like in the physical world. You're seeing applications of this across a number of spaces. So if you combine, again, this idea of solving the double spending problem with the ability to define scarce digital assets, you get things like Bitcoin, which is like digital gold at the moment, mostly because it's a terrible medium of exchange. Bitcoin is a property right on a piece of code, on a string of what people call an unspent output, like a balance on the Bitcoin ledger. It's essentially a piece of code. It's digital information. But now it's quite powerful because as long as people believe it has value, it can be used to transfer value. And this is where I think a lot of people get confused because they're like, well, wait, but fiat money has the government behind, the whole economy, so we trust it because there's something behind it. Well, it turns out that money, since the beginning of history, it's been a social construct. Money has value because we believe it has value. And maybe in the United States it's more counterintuitive because the money is pretty sound, but go to any country where that's not true and you realize that money and Bitcoin, fiat currency and Bitcoin have more in common than you'd think. Other things you can do is take something like computation, Ethereum, and again, turn it into this digital asset that can be traded and exchanged on a global scale very effectively. This is something we didn't have before, the ability to really buy and sell computation services on a spot market. Here's where it gets even more extreme. Take file storage, data storage, right? So right now you can buy data storage from the cloud. It's a fairly concentrated market. Amazon and others enjoy pretty good margins on that service. But what if I tie storage to a cryptocurrency? Now, if I freeze disk space on my drive or spare space on a data center, I can lend it to the network. And I've created a spot market for data storage. And anybody that needs data storage will pay the instantaneous price, very much like in a financial market. I've taken a physical resource and I've digitized it, and I created a spot market around it, an extremely competitive market around it. Now, of course, when people think about taking digital assets that didn't exist before, you get things like CryptoKitties, which is collectibles on a blockchain. And people tend to underestimate this. But go back to the early days of YouTube. YouTube started with cats on the internet. So be a bit careful in dismissing CryptoKitties, mostly because from an economics perspective, it's a brilliant implementation of what the technology is good for. Creating digital assets that are scarce, in limited supply, they're unique, and they're programmable. So without going into too much detail, these are cats that will breed with each other, generate new varieties according to a genetic code, and there's a limited supply. And some of these have sold for thousands and thousands of dollars because collectibles have a history and people care about collectibles. And so collectibles of the futures are going to be digital. In a digital space, a digital collectible that's unique and cannot be counterfeit is going to be much more valuable than a physical collectible. Where people get a little bit confused with blockchain is that then they start taking the problem and saying, OK, we can apply it pretty much everywhere. And then they, as I was mentioning before, they often forget that digital goods have such interesting properties that physical goods don't always have. So let's say you want to track goods on a supply chain using this kind of distributed ledger, this database, right? If you do it for diamonds, the last mile problem is slightly less severe because diamonds have physical properties, right, that are sort of unique. You could record that, and it could be kind of a digital fingerprint for that object. But if you're doing it for food, now the question becomes, if that shipment of food of any type gets altered or the temperature rises or anything that you're worried about through that supply chain changes, that information is not going to be ported online on its own. So you need an intermediary. It's going to be an agent or a trusted sensor, GPS device, temperature device, whatever you need to complement blockchain with to make sure that that information that you're interested in is reported online as quickly as possible. So when you think about blockchain applications, a big part of the opportunity that I think a lot of entrepreneurs are underestimating is that if the cost of digital verification goes down dramatically, think about basic complements, right? So economics 101, if one input goes down, the complement to that, which is offline verification, will become extremely valuable. So blockchain is not really about removing intermediaries, which was kind of the narrative in many of the books that you may have found in the bookstore at the airport. But it's about creating new types of intermediaries, and it's about changing what intermediaries spend time and resources on, including banks and financial institutions. It's not about removing them from the market. It's about saying, look, now we can use technology to do a bulk of the settlement and reconciliation that you're doing through legacy infrastructure that's completely outdated, siloed, and has a number of problems. We can replace all that, and we can make settlement and reconciliation extremely cheap. Now, of course, for incumbents, that's a problem because part of your revenues come from being able to charge $45 if I send a wire from the US to Europe, right? So that's, of course, putting competitive pressure. But it's also opening a wealth of opportunities, because now if financial services, financial assets, currency, and payments become extremely cheap, we're going to consume a lot more of them. We're going to consume them for things we wouldn't have found practical to consume them for before. So it's not really about costless verification. I kind of lied when I said, blockchain allows you to do the costless verification of digital attributes. It's, yeah, I said the data is totally accurate, right? It's about bridging that gap between digital information and the offline record in an extremely efficient way. And that's where, if you're in the IoT space or if you're an intermediary, thinking cleverly about the fact that now I can verify digital attributes extremely cheaply on a global scale. But on the other side, there's that last mile problem. Take remittances, right? Why didn't blockchain or Bitcoin solve remittances and make remittances extremely cheap? Why are people paying so much for remittances till today? Well, the problem is that on the two ends, take the bodega in New York, right, and the last mile with a small business owner in the middle of nowhere in Africa, that last mile is still expensive. Now, of course, we have mobile phones, so over time we can close the gap. But those two ends between the blockchain in the middle is still expensive. I promised you two costs. And this one is the one that 10, 15 years from now will change pretty much any digital platform as you know it today. So what is really blockchain technology about? It's a technology that allows a network of economic agents, here it's going to get a little bit theoretical, to agree at regular intervals about the true state of some shared data. So let me bring it down to an example. Think about Uber, right? So it's a network of drivers and customers that need to agree regularly, instantaneously, about rides, reputation systems, payments, right? And everything else on a sort of distributed network. If you put those three things together, you realize that any digital platform as you know it today, including financial institutions, that's what they do. They're digital marketplaces. So you can use blockchain to bootstrap new types of digital marketplaces. Now, of course, you may not want to do this everywhere. If you have a very efficient digital marketplace, you're not going to displace it just because you're adding blockchain on top of it. But where your marketplaces, where the digital incumbents have tremendous market power, you can use the technology to compete on better terms. So think about what are the consequences of market power today? Well, first of all, when you think about anything digital that you use and love, you don't own it. You're renting it, probably from a large company. Your Gmail, your Facebook account, you don't own any of that. In fact, the content you generate in some cases is not even yours anymore. So data ownership is different. Prices could be higher. And often, this is counterintuitive because we don't pay for many of these services, right? So somebody else is paying. In the case of Google or Facebook, the advertisers are paying, right? Because the market power is expressed on that side of the market. Single point of failure. When Amazon Cloud goes down, a number of websites go down with it. The internet is kind of extremely vulnerable from a cybersecurity perspective. And also barriers to entry. If you want to enter and compete with some of these players, it's extremely difficult today. So if you take that reduction in the cost of networking seriously, what can you do with this? Many things. From crowdfunding, which is kind of the ICO space that I'll show you some data on in a second, to new types of digital platforms, software protocols, public goods provision. From a government perspective, there's a massive upside in rethinking how the government delivers services. And data ownership and licensing. A lot of the last few months have been a heated debate about data ownership, how that data is being reused outside of what the users have agreed on some of these platforms. And so it becomes really important to think about how can we use this technology to fix some of those problems. And for those of you that are more on the economic side, well, you can build really clever auctions. Turns out that auctions are quite useful, and you can build really clever ways to do auctions. So let's jump into really tokens, because that's kind of the new frontier in all of this, the use of these cryptocurrencies and crypto tokens to build these digital ecosystems. I want to start with a series of pictures. So let's think about what happened with Bitcoin. Someone, she, he, or they wrote some code on the internet, and that code said the following thing. If you attach your hardware, your computers to this network and help secure it, in a decentralized fashion, attach your laptops, your desktops, and over time your data centers, you'll be rewarded. It's going to be a limited supply of this digital good. It's going to be provided over time. And if you join early and this network becomes more useful, that token will appreciate in value. And that graph shows you kind of the market cap of Bitcoin, including the spike during the hype phase over time. So that contract that somebody wrote was actually true until today and until someone comes out with something better. But let me show you in pictures what that means. So it started like this, right? Some amateurs in a garage. The first ones that could read the code, the cypherpunks, they were like, oh, I understand this. There's a limited supply. It's based on cryptography. And I read the incentives. I understand it. Let me attach my laptop. These are the days where someone bought 2 pizzas, probably not even that good, for 10,000 Bitcoins. Probably the most expensive pizzas in history. Because Bitcoin didn't have any value. The community was small, and nobody believed this network could succeed. Then, of course, greed kicked in. And people realized, oh, the original vision of Satoshi was 1 CPU, 1 vote. Very democratic. 1 computer, 1 vote. Well, people realized, well, I can use my graphic card to vote as I was a small municipality and go faster than everybody and mine more Bitcoins. To the point that now Bitcoin is mined on state-of-the-art silicon, ASICs. State-of-the-art data farms. And so it's not this anymore, but it looks a lot more like that, right? And that's sort of both terrifying and exciting. So the terrifying part is that someone wrote code over the internet, and 10 years later, we have data farms all over the globe solving useless cryptographic puzzles, and making climate change in the long run even worse. But the exciting part is that someone used incentives to bootstrap digital infrastructure. This is essentially the first time in history that we deployed a global financial-like network without any investments by a government or a large firm or any concerted action by a set of firms. Someone wrote code on the internet, and on the other end, we have a global financial platform. Now, of course, Bitcoin has a long way to go to scale. And there's challenges. There's a number of other approaches. But what's interesting here is that people have seen this model of coming up with an idea and coordinating economic activity on a global scale. Essentially, it's a new type of firm when you think about it. And I'll show you some examples. I've taken that template and are now reusing it for other things. And maybe without some of the negative consequences like mining. That's the concept that has led to a proliferation of new experiments. And I'll show you in the last 15 minutes some data on this. Why was there such an explosion in activity? It's because it takes 75 lines of code to launch your own token. So you have our students in their dorm launching tokens. You have entrepreneurs across the globe launching tokens. You have very serious teams. And then, of course, scammers and fraudsters that have realized that they can mold with the broader crowd and pretend they have a serious idea. It all started on the wrong foot, the DAO, which was kind of a decentralized venture capital firm. Now, there was a bug in the code, and if you read the Wikipedia page, you would have been kind of terrified in the first place, because like number of employees, 0, automated. Era served Word, and it's stateless, which is probably not the best for a new type of institution. There was a bug in the code, which kind of shows where the technology is still fragile, and people siphoned off $50 million. But that model has really exploded. To the point that if you were anywhere close to the news in December of 2017, this tulip bubble analogy started floating. Now, it turns out that many journalists are sloppy, because even the accounts for the tulip bubble are not accurate. The tulip bubble was not completely rational. In fact, it wasn't a bubble at all. So a historian from UCL rebuilt some of the historical accounts and realized that most of the stories that have been told about tulips are based on the satirical accounts of the Dutch writers, which, if you base today's accounts on the satirical accounts, I think, or the real accounts, it's probably the same in these days, you may get the wrong picture. So what we did is collect data, because we wanted to get more insight on what is actually going on. How many of these new tokens are actually frauds and scams versus serious projects? This is the explosion in activity. We had started collecting data actually in 2015, and we were like, OK, it's going to take a while to have an academic paper on this because there's not enough data. And then 2017 happened. It's like, OK, now we're behind. 1 out of 4 of these tokens doesn't raise any money. So it's 0 to 5K. But look at the average size. This has already eclipsed angel and kind of even early VC. The average size is 1 to 5 million. So for many countries that don't have an angel or venture capital ecosystem, this is a way to bootstrap startup activity. Now, there's a number of issues at the moment, but once it's going to be sort of regulated and brought back into the right space, it has the potential to move capital without frictions on a global scale. The majority of the capital is actually concentrated on the right tail of that distribution. And this is, for those of you that were here when I presented the data on crowdfunding a few years ago, it's very similar to crowdfunding. It's a blockbuster economy. The top projects bring home most of the funding. Now, if you look at the age distribution, this is where I got a little bit depressed. I was like, these teams are extremely young. So it's centered somewhere around 25, 24. It's a new type of entrepreneur. When you look at their credentials, this is where we launched this new research lab at Sloan called the Cryptoeconomics lab. And my joke is at the moment is that there's really bad crypto and not a lot of good economics in cryptoeconomics. But the profile exists in the wild. So these are people that have background in computer science and background in business, finance, or economics. The same person. These are not two different team members that bring that together, as is often observed. Many of the founders in this space are extremely young, and they have a very different background than your classic entrepreneurs. Because you need to know cryptography to build anything in this space, despite what some people believe. So where are these ICOs, this initial coin offering, so the sale of these tokens in exchange for money taking place? Well, most of them are in the United States. So the data of Silicon Valley, as some people have painted it, is far from the truth. Most of them are in the US, but there's a range of countries on this map where you see activity. When you look in terms of capital, it's way more skewed towards the United States, and in particular, California and New York. But what's interesting is that other regions are trying. And you have regions like Eastern Europe, where you have great coders, great cryptographers, but not a lot of angel and venture capital money going around, as in the United States. Where are the investors located? Well, pretty much everywhere across the globe. So here you're looking at kind of the supply of capital side. Now, many of the people investing in this are people that have made a lot of money, maybe on Bitcoin and then on Ethereum, and now are diversifying, quote unquote, their returns. But it's interesting to see that the amounts moved are quite substantial. If you compare it directly to Series A funding per capita, here on this graph, any country above the diagonal has received more funding through ICOs in 2017 than through traditional VC. Okay? And look at the names, like Singapore and Switzerland, which are two of the countries that had more clear legislation on the topic, are way above the diagonal. And in fact, even the United States is not that far from it. If you look at traditional accredited investors, qualified purchasers, and institutions in the US, where is most of the activity taking place? Well, some of the usual suspects, right? The two coasts and some of the other hubs with entrepreneurial activity. If you compare it to seed capital, even California is above the diagonal. So if you think of California as the canary in the coal mine, well, things are switching in that space too. And again, part of this was driven by the extreme hype of 2017, so it'll probably come down. But it shows that the mechanism can work at that scale. And in fact, I don't have the time to go. We have an old theoretical model where we compare it to equity financing. It's much more of a complement to traditional venture capital than a substitute. They're doing different things. Now, what's the performance of these assets? Well, it turns out that there's been a lot of enthusiasm. So the majority of them are underwater. So they're trading below. If you look at the last bar, it's about 50%. So of the core that launched early in 2017, about 25% is underwater today. And it's been increasing because there's been excessive entry. People have seen this. They've seen that they can raise capital, including our students. They've rushed into this. In the paper, we kind of separate, is the market completely irrational as people have been painting it, or is there any logic? So what we see is that most of the money today is flowing to teams that have very technical white papers. You can think of them as scientific papers that talk about the technology. Plagiarism, like in school, is not rewarded. So people that have kind of copy and paste technology from other teams are not receiving the majority of the money. The more developed and engaged your open source code base is, the more likely you are to raise funding. And again, the economics of the business model that you're building here are fundamentally different because by design, you won't own your IP. It's going to be open source, and everybody will be able to fork it and copy it. The stronger the technical teams, and here we went and collected the profiles of about 8,000 individuals involved in these ICOs, the ones that receive the most funding have deep expertise in computer science, cryptography, and everything else. Now, does that say that teams with poor quality and skills are attracting capital? Yes, some of these teams are also attracting capital. And we have assessed that frauds and scams are pretty high. So it's between 6%, which is the lowest estimate we could find, which is clearly identified cases of frauds and scam, to as much as 25%, 1 every 4. Is likely to be some sort of exit scam or team that is not really serious. Now, on top of that, there's going to be a segment of entrepreneurs that don't have the technical or business expertise to actually deliver on what they're promising. This was very similar in the early days of Kickstarter, where 75% of projects didn't deliver or delivered late. I think you'll see a very similar dynamic as the market matures. Now, many have talked about a crypto valley, so essentially a new region that could absorb a lot of the talent and entrepreneurial creativity in this space. And Switzerland and Singapore have been quite strategic in trying to attract many of these teams. What's interesting is that regulation is actually helping. In places where there's been clear norms of what you can do, what you have to disclose, how do you run one of these ICOs, we've seen less frauds and scams. So the uncertainty, if anything, is helping the bad actors to mix with the good actors. And again, it's much easier to enter as a bad actor because you don't have to actually have a product relative to, or a product idea at this stage, than a bad one. And on all accounts, the favorable legislations have been performing well. So they have attracted some of the teams that we would want to nurture. And these are new business models, new ideas for really building those decentralized and digital marketplaces that I was talking about. Now, people have been too focused on using these tokens just to raise capital. But the potential of these tokens is actually much broader. And in the last few slides, before we open up for questions, I'd like to highlight what can you do with these tokens that you couldn't do before. Of course, I can exchange a token in exchange for financing. So that's kind of a crowdfunding use case. But I can also use that token to align incentives between different participants in a digital marketplace. Let me show you some examples. Let's say I want to compete with the cloud, as we know it today on the left, fairly concentrated market with fairly high margins. And I want to create a global platform for anybody that needs data storage. Different requirements, different needs. I essentially write code saying if you attach hardware, if you attach your hard drive to the network, you'll be rewarded, like in Bitcoin, right? And now I have something like Filecoin or SIA. What these platforms are doing, they're decentralizing data storage and making it an extremely competitive marketplace. Now, what's interesting is that think about something, a business like Akamai, or a machine learning company that's really good at predicting things of different type. If you have data storage on an open decentralized platform like Filecoin, what I can do is I can monitor the network, and now I start observing that maybe around 8 p.m., a bunch of large files starts moving around. And I don't need to know that those are Netflix's latest shows. I can be a pure prediction company and start serving those files faster for a small fee. You've reinvented a service on top of storage with very low entry barriers. So you're really changing market structure. So you can use these tokens to build infrastructure that you don't need to build yourself, like data storage or bandwidth or electricity, whatever is needed to run a business in a decentralized way by just writing the right incentives in your code. You can use that same code to attract top talent. Think about hedge funds today. The way they work is essentially, right, you have a bunch of data scientists doing predictions on financial data. You invest, make money, repeat. So how would you build a hedge fund on a cryptocurrency? you would say, I don't know where the best talent in the world for data science is. And in fact, I'm pretty sure that no matter how good my hedge fund is, there's going to be some good people that are not in my firm. So let me turn this into a prediction problem. Take financial data, I encrypt it, I give it out publicly, and now data scientists across the world can compete in selling me their predictions. I take their predictions, I invest based on them, and I write a smart contract. This is where blockchain becomes kind of interesting, that maps their returns to the quality of those predictions. I'm writing a digital contract with them, and essentially I'm turning every data scientist with talent across the globe into an early equity owner and employee of my decentralized firm. This is what, for example, Numera is doing. Now, for those of you that are familiar with platforms like Kaggle, right, where companies open up data sets and they have crowd-solve, it may sound familiar. It's not. In Kaggle, the data scientists have no ownership stake. Their incentives are not aligned. They're coming in for that single competition. They're not your employees. In this regime, they're never overfit their data. In Kaggle, they might. If they can overfit just enough to win the competition, you're ending with a worse prediction model because their incentives are not aligned with yours in the long run. But in the Numera case, you're using the token to align incentives between those data scientists and your own goal. Okay? You can also use those same tokens to solve the classic chicken and egg problem in digital platforms. How do you get people to move from your competitors or incumbent platform to join yours? No matter when you join Facebook, you had the same utility out of Facebook, right? Early joiners that actually de-risked the experience for everybody else didn't earn anything. But what if I were to launch a platform and now give early adopters tokens in that platform? As the digital platform increases in users and in value, those tokens would appreciate too. And now I've found a way to reward early adopters for taking risk in my product. And if you want to read a bit more about how important that can be, when we did the Bitcoin experiment at MIT, in cases where we seeded the technology optimally, essentially incentivizing early adopters, and in cases where we did not, we had 45% difference in activity almost 300 days into the experiment. So early adopters can really accelerate the diffusion of your technology. And just imagine what that means once you add incentive, essentially fuel to the fire on top of that. Now, of course, you heard a lot of positives, but where are some of the landmines in this space? Well, think about the basic idea. You take marketplaces that are run by one centralized intermediary often, and you're replacing them with technology, code, incentives. Now, if anything goes wrong there, how do you govern that platform? How do you get it to upgrade? So governance is really the Achilles heel of all these implementations. In fact, even for Bitcoin, the biggest problem has been governance. How do you get Bitcoin to scale so that we can actually use it for payments on a global scale? So when you're taking that intermediary out, how do you develop really the governance for these new models is an open question. And people have been looking at open source. The challenge has been that open source has never had so much money at stake as these platforms, which are already worth hundreds of millions, if not billions of dollars. With that, I'll open up for any questions you may have. Oh, we're out of time? OK, thank you.